This is the study guide for the Algebra 1 factoring test. There are many different ways to factor. The number one way that you always should consider when factoring, the first thing you should do is to factor out the GCF. Once you've identified the GCF, from there you can utilize different types of factoring. There's a difference of two perfect squares, which is one you should certainly check for. Then there's factoring by grouping, and factoring where the coefficient, the lead coefficient, is not 1. There are different methods for doing them, especially type 5 factoring. For me, I generally do guess and check. You're going to see a lot of guess and check from me. A polynomial is considered fully factored when there's nothing else that can be taken out. Each one is considered prime. And then solving is just taking those factored polynomials and understanding that in order for it to equal 0, one of those two things need to be 0. Let's go through these. The first couple ones just ask us to factor. It says to factor completely. First thing we're going to consider is a GCF. Which do both of these terms with binomial have in common? They both have a 2. So I'll factor out a 2. It's just x plus y. There's nothing else to factor in there. You should consider that. If you want, you can always check by redistributing. 2 times x is 2x, 2 times y is 2y. This is fully factored. B. First, let's check for a GCF. Well, there's nothing with the numbers, the coefficients, 7 and 30. Actually, I think about 7 goes in both of them. I apologize. And W goes in both of them, but there's 2 W's in this, and there's 5 W's there, so I can take out all of them. So there's no more coefficient, but there is a W cubed, and there's a -5, and the W's are now gone. In these situations, if you're confused, you can, again, always distribute it back out and just make sure. 7W squared times W cubed would be 7W to the 5th, which is what I had. And 7 times -5 is -35, and there's the W squared. That's what I had. That's not my answer. I'm going to erase it. This is my fully factored form. There's nothing else that comes out of here. It is the difference, but neither of these are perfect squares. For C, you can immediately look at this as the difference of two perfect squares because it is. It's subtraction, and both of them are perfect squares. However, you should first consider that there's a GCF, which is 25. 25 goes into both of them. That makes it x squared minus 4. At this point, you're not done because this is still the difference, which means subtraction of two perfect squares. So 25 times square root of x squared is x, square root of 4 is 2, 1 is a plus, 1 is a minus. This is your fully factored form. Even if you consider those the difference of two perfect squares and did 5x plus 10 times 5x minus 10, what you had forgotten is that there's a 5 in here, and there's a 5 in this one, and 5 times 5 is that 25 that's out front, x plus 2x minus 2. This is my fully factored form. So if you miss the GCF, you still need to eventually get the GCF out. D, consider a GCF. There is no GCF, so I'll go right into factoring. The only way to get x squared is x times x. Since this is a plus, that means they're both the same. Since this is a plus sign, that means they're both pluses. 18 has many different ways to get it. 1 and 18, 2 and 9, 3 and 6, 4, no, 5, no, and back at 6. Since it's the same, that means we find the sum. 2 and 9 is our fully factored form. E. Again, no GCF. The only way to get n squared is n times n. Since this is a plus sign, that means they're both the same. Since this is a minus, that means they're both minuses. Ways to get 8. 1 and 8, 2 and 4, and that's it. Since they're the same, that means sum 2 and 4 is what we're looking for. Does it matter if you had n minus 4 times n minus 2? No, of course not. That's the commutative property of multiplication. Either one would be sufficient. F looks tricky until you remember your rules, which is to remember that you need to find the GCF. In this case, the GCF, we want our lead coefficient to be positive, so I'm going to factor out a -1. Leaving y squared plus 2y minus 15. So the -1 needs to come down. A lot of students forget the -1. Make sure you bring the negative coefficient down when you come down. The other way to get y squared is y times y. 15, however, I'm sorry, this is minus, which means they're both different. One's a plus, one's a minus. They're different. Another way to get 15 is 1 and 15 and 3 and 5. Since it's different, so we're going to find the difference. The difference is 3 and 5. 5 goes here, 3 goes here. You still should verify, check, by actually checking. 5 times y is positive 5y. Y times -3 is -3y, which adds up to 2y. And positive 2 is what I had in the middle. Well, it's great that I checked all that. Just to make it clear, the answer is this with the -1 out front. If you don't put this negative 1 out front, you're not fully factoring it, and it's incorrect. You need to have all the things that make it what it is. G, H, and I asked us to continue factoring, so I'll continue factoring with G. First thing I'm going to look for is a GCF. There's no GCF besides 1. To get x squared, that's x times x. Since this is a minus, that means they're different. 1 is a plus, 1 is a minus. 24 has many different ways. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So many different opportunities to get it. Since they're different, we're looking for the difference. The difference is the number in the middle. It's 4 and 6. 6 and 4. Here's my fully factored form. H. It's going to be tricky because there are many different possibilities for H. With H, look for a GCF. There's no GCF other than 1. So things get a lot trickier when the number out front is not 1, especially if you're going to use the method of guess and check. So I hope I get lucky. We'll see. Ways to get 8x squared is either 8x times x or 4x times 2x, both of which are different. So I'm going to try 4x and 2x. Again, I don't know what the answer is. I'm just going to guess. I do know that this is a plus, which means they're both the same, and I know that the minus, which makes them both minus. That makes things easier. And it also makes it easier that the only way to get 3 is 1 and 3. So this is a 1, this is a 3, or this is a 3, and that's a 1. Let's check. Negative 1 times 2x is negative 2x. 4 times negative 3 is negative 12x. This is negative 14x. It's not correct. So let's switch the 1 and the 3 and see if we get something better. 3 and 1. Negative 3 times 2x is negative 6x. 4 times negative 1 is negative 4x, which is negative 10x. Not bad, I got on my second guess. This is my fully factored form. I. Going to look for a GCF. There's no GCF other than 1. Since there's 2 of them in subtraction, you should immediately think the difference of 2 perfect squares, and that's what it is. X to the 4th is a perfect square because the square root of x to the 4th is x to the 2nd power. X squared, 1 plus, 1 minus, the square root of 1 is 1. You might consider stopping. However, if you stop, you'd run into the issue that this is, again, this one right here is the difference of 2 perfect squares. This one is not, it's the sum of 2 perfect squares. But this one is a perfect square. Square root of x squared is x, 1 plus, 1 minus, and again, the square root of 1 is 1. Here's my fully factored form as a nice, tricky one. Question number 2 asks us to solve. In order to solve, what we need to consider is this fact. If I have 2 values, let's call it A and B, and I know nothing about these 2 numbers except that when I multiply them it equals 0, that means, and this is only with multiplication, either A equals 0, B equals 0, or they're both equal to 0. There's no way the 2 numbers can multiply, and again, this only applies for multiplication, for it to equal 0. There's no other way for it to equal 0 unless one of them is 0. This could be 12 as long as this is 0. Nothing else, even negative 3 and positive 3, that gives us negative 9, does not give us 0. So the concept that we need to understand is that in order for 2 things to be equal to 0 if they're multiplying, one of them has to equal 0. So when this has to solve or find the roots, the x-intercepts of the zeros of the solutions, we really want to focus on this concept of the zeros. What number will make it 0? Now, A is already set up in a situation where these has been factored, where it's this quantity times this quantity equals 0, which means either 2x minus 3 is 0, or this quantity, x plus 2, is equal to 0. One of those 2 things has to equal 0, so I add 3 to both sides. 2x equals 3, divided by 2, divided by 2, x equals 3 over 2. If I plugged in 3 over 2 into x, it would turn the whole quantity into 0. Minus 2, x equals negative 2. If I plugged in negative 2, that would also result in it equaling 0. In other words, when we graph this, if I were to graph it, it's going to cross at negative 2, and it's going to cross at 1.5. How far down will it go? Well, that's something for us to talk about another day, but it's definitely going to cross the y-axis, or the y-intercepts, at 1.5, or 3 over 2, and negative 2. So as my roots, my x-intercepts, my zero solutions are all the same thing. In this case, negative 2 and 3 over 2. B, we're not so lucky, it's not already factored for us. We need to set it equal to 0. It's all about setting it equal to 0. So this is not set equal to 0. X squared plus 3x minus 18 equals 0. Now it is set equal to 0. I moved it over. What you're not going to do is you're not going to say, oh, each one of these things, so x squared equals 0 and 3x. This is not what you're doing. There's no concept that says, like, add two numbers and equals it. That means one of these two things has to be 0. As a matter of fact, quite the contrary. Not all of these things has to be 0. It's more likely this is anything other than 0. But 0 won't necessarily work. So it only works with multiplying. So in this situation down here, B, I'm not setting each section equal to 0. I'm not doing that. First, I need to factor. I need to figure out that we're multiplying two things. So all about multiplying, and that's what factoring does. Allows us to set up when we're multiplying two things. X squared is x times x. Since this is minus, 1 to plus, 1 to minus. 18 is a whole bunch of stuff. 1 and 18, 2 and 9, 3 and 6. Since it's different, it's difference. This is 6 and 3. So these are my two factors. X plus 6 equals 0, or x minus 3 equals 0. So x equals negative 6, and x equals positive 3. Now what that means is if I took the original right here, and I plugged in, or even this one, if I plugged in negative 6 or positive 3, this would turn the whole thing to 0. X squared plus 3x minus 18 equals 0. If I plugged in negative 6 squared plus 3 times negative 6 minus 18 equals 0. Negative 6 squared is positive 36 minus 18 minus another 18 equals 0. 36 minus 18 is 18 minus 18 equals 0, and 18 minus 18 is 0 equals 0. As we said, negative 6, also negative 3 would be the two things that make it equal to 0. I'm going to clear this all out. So that's some space for C. This is already set equal to 0, but I need to factor it. X squared is x times x, 45, many options, 1 and 45, 2 no, 3 and 15, 4 no, 5, yes, 5 and 9, that's about it. Since this is a plus sign, they're both the same. Since this is a minus, they're both minuses. 14 is 5 and 9. You got to factor correctly to do the next part. Either x minus 5 equals 0, so x equals 5, or x minus 9 equals 0, so x equals positive 9. These are my zeros, my roots by x-intercept solutions. Again, if I were to graph this, this would cross at 1, 2, 3, 4, 5. And 6, 7, 8, and 9 is going to cross there and there. It kind of looks something like that. Now that we understand the basis of solving, I'm going to move a little bit quicker with solving. It's essentially just factoring first. Set equal to 0. Let's factor this. It's x and x. This is plus are both the same. This minus are both minuses. It's 5 and 5. So either x minus 5 equals 0, x equals 5, or x minus 5 equals 0, x equals 5. So so there's only one solution, 5. If I were to graph this, 1, 2, 3, 4, 5, it doesn't actually cross, it just sort of touches and then goes back up. You can always verify by using your graphing calculator and graphing it. E, got a factor, 2x and x. This is minus and 1's a plus, 1's a minus. I got some guessing and some checking to do. I'm going to start with that. I have no idea. I'm going to guess and check where I know that 35 is 1 and 35, which is usually an extreme, or 5 and 7. I'll start with 5 and 7. I'll start with 5 here, 7 here. 5 times x is 5x. 2x times x is negative 14x, which is negative 9x. I wanted negative 3. So I messed up someplace. One of them is wrong. I'm going to switch to 5 and the 7. 7 times x is 7x. 2x times negative 5 is negative, 10x, which is my negative 3x. That's what I wanted. This is my factor form. Not done. Since I know they're multiplying equals either 2x plus 7 equals 0 or x minus 5 equals 0. X equals negative 7 over 2 when you solve, and x equals positive 5 when you solve. Those are my zeros, roots, x-intercepts, or solutions. You can always graph it to check. I'm going to clear all this out so I have some space again. This is not set equal to 0, so I'm going to have to set it equal to 0. We actually shouldn't even do this one. All right, you're not responsible for 3F, but I'll show you how to do it. You probably would use the grouping strategy. M cubed minus 3m squared minus 4m plus 12 equals 0, and you bring it all over. So this is actually a technique known as grouping. M cubed minus 3m squared minus 4m minus 12. If you notice, I put parentheses around this, and this became negative. So I essentially factored out a negative. Negative 4 times 4m is negative 4m. Negative times negative is a positive. Let's find the GCF of each of these. This is m squared, m minus 3. And this is pull out a 4, m minus 3 equals 0. If you notice, they both have an m minus 3, which is what we want. And I'm left with an m squared minus 4. We continue factoring. There's a nice hard one. Of all the ones to do, there's a nice difficult one. This is still m minus 3. This is now the difference of two perfect squares. M and m is subtraction, 1 plus, 1 minus, 2 and 2. I have three things, so each of them we said equals 0. Either m minus 3 equals 0, or m plus 2 equals 0, or m minus 2 equals 0. M equals positive 2, m equals negative 2, and m equals positive 3 once you solve. There's 3 zeros. If you were to graph it, you'd notice that this probably does something like this. It crosses at negative 2, it crosses at positive 2, and it crosses at positive 3. So it's going to do something like this. Nope, sorry. Something like this. Probably more like that. But again, you're not responsible for one like that. You probably won't see something like that. As a general rule, if the highest power is 3, if it's degree 3, there's going to be up to 3 solutions. In this case, there are 3 solutions. Let's do G, which is one you're more responsible for. Don't forget, first thing you should look for is a GCF. This is now 7a plus 2 equals 0. Since they're being multiplied, either a equals 0, this thing, or 7a plus 2 equals 0. When I solve this minus 2 minus 2, 7a equals negative 2. A equals negative 2 7, so it's one of my solutions. And a equals 0, that's my other solution. H, nice one. First thing we should look for is a GCF, which in this case is 6 and x. This is x squared minus 6x plus 5 equals 0. So again, I factored a 6x. If you want to check, 6x times x squared is 6x cubed. 6 times 6 is 36. X times x is x squared. 6x times 5 is 30x. Still not done, because I have to factor this trinomial. X and x. This is pluses are both the same. This is minuses are both minuses. The only way to get 5 is 5 and 1. Now we have, again, three things being multiplied. Either x minus 1 equals 0, or x minus 5 equals 0, or 6x equals 0. Divided by 6, divided by 6. X equals 0 divided by 6 is 0. Don't fall into that trap. It's 0. X equals 5 right here, and x equals 1 right here. There are three roots where zeros are x-intercepts. And if I were to graph this, it would cross at 0, the origin. It would cross at 1. It would cross at 2, 3, 4, 5. Again, I would expect it to do something like this if I were to graph it. It crosses 3 times. It has 3 roots. X-intercepts are zeros. 4, again, it asks you to find the zeros. All this means is set equal to 0, f of x is 0, 7x squared plus 2x minus 5. It is a nice, fancy factoring one. 7x and x is the only way you can get 7x squared, because my a is no longer 1. This is minus, so 1's a plus, 1's a minus. I'm just going to guess plus minus. The nice thing is 5 is either 5 and 1 or 1 and 5. Since it's not too big, see what happens. 5 and 1. 1 times x is 1x. 7x times negative 5 is negative 35x, which is negative 34x. Not quite the 2 that I was looking for. Let's try it again, except switch the 1 and the 5. 5 and 1. 5 times x is 5x. 7x times 1 is negative 7x, which is negative 2x. That was the number I was looking for, 2, but it was the wrong sign, which means I'm probably on the right track, except my signs are backwards. So let me just flip these signs around and make this a minus and this a plus. Now I've given my factored form. Now I got to solve. Either 7x minus 5 equals 0, so x equals 5 sevenths when I solve correctly, or x plus 1 equals 0, so x equals negative 1. Again, find the zeros, the same as the roots of the x-intercepts for the solutions. For b, set equal to 0, 5x cubed minus 30x squared plus 40x. First thing we should look for is a GCF, which to me looks like 5x. This is again x squared minus 6x plus 8. Once you find your GCF, things become a lot easier. 0 equals, don't forget to bring on the 5x. X and x is plus is both the same, there's minuses are both minuses. 8 is a lot of things, but 4 and 2 is what we're looking for. So now I have 3 things set equal to 0, either 5x equals 0, so when I divide by 5, again, 0 divided by 5 is 0. X minus 4 equals 0, so x equals 4. Or x minus 2 equals 0, so x equals 2. They are my 3 roots. If I were to graph it, it would cross in those 3 places. Let me, again, clear some space. For C, set it equal to 0. 6x squared minus 5x minus 14. A lot of ways to do this. This is even harder than you think, because 6x is not only 6x squared is not only 6x and x, it's also 2x and 3x. A lot of things it could be. I like to start with the 2's and the 3's just because. Let me try 3x and 2x. Since this is minus, that means they're both different. One's a plus, one's a minus. 14 is 1 and 14, or 2 and 7. Let me give you a hint with a lot of these. There's no way that this could be a 2 here and it can't be a 14 here. In other words, the positive can't be here. The reason the even can't be here. The reason I can't have an even here is because I have an even here. If this were a 14, that means I missed a GCF. I could factor out a 2. But since I couldn't factor out a 2 here, it means I can't factor out a 2 there either. Same thing goes with the 6x. Couldn't match up the 6x with any even 2, because this would require me to have a GCF. But since there's no GCF here, there won't be a GCF there. So it's either a 7 here and a 2 here, or it's a 1, sorry, I just did the opposite. 2 here and a 7 here, where they're not GCFs, or it's a 14 and 7. Let's see, 2 times 2 is 4x, 3x times negative 7 is negative 21x, which is negative 17x. Definitely not correct. And since I know that the 2 can't be here, that means I'll try 1 and 14. So 14 here and 1 here. 3 times x is negative 3x. 14 times 2 is 28x, which is 25x. Definitely not right here. So, all right. So I don't think it's the 6 and the 2. Again, I can't put a 14 here, because if I put 14 here, 2 and 14 has a GCF of 2. So let me not do 2 and 3. 2x and 3x. Let me try 6x and x. The plus and the minus don't really matter for now. 14 is still 1 and 14 and 2 and 7. Again, I can't put a 2 here. I cannot, because then I'd have a GCF of 2, and since there wasn't one there, I won't be one there. So let's try 7 here, 2 there, see if this works. 7 times x is 7x. 6x times 2 is negative 12x, which is my negative 5x, and that's what I was looking for. So I found it. One of these two things are either, since they multiply by 0, one of these two things equals 0. Minus 7 minus 7, 6x equals negative 7, x equals negative 7/6. Or x minus 2 equals 0, so x equals 2. Those are my two roots, x-intercept, zeros are solutions. If I were to graph it, it would cross one of those two spots. And then question number 5, the length of a rectangle is 7 inches more than 5 times its width. The area is 6 square inches. What's the width? This seems like a tricky question, but they actually did a lot of labeling for you. The length is 7 more than 5 times its width. So 7 more than 5 times its width. It drew a picture for you. It says the area is 6. What's the width? All right, so we know this about the area of rectangle. Area equals base times height. So area equals, well, what's the, or length times width, if we want to use the same terminology as before. Length times width. What is the length of this rectangle? They said it was 5x plus 7. What's the width of this rectangle? They said it was x. Now it seems like, how in the world is that going to help me? It doesn't seem any better. I just have a bunch of variables. But then they also said, oh yeah, the area is 6. So A is really equal to 6. So now we're in a situation where you might be tempted to set them equal to 6. That's not true. If I have two numbers that be multiplied equals 6, you can't tell me anything about either of these numbers. This could be negative 2 and negative 3. This could be 1/6 and 36. There's many different things that it could be, so that doesn't really help us. It's only when it's set equal to 0, then I can say one of them equals 0. So let's do this. I'm going to multiply this back out and assume someone factored in correctly. 6 equals 5x squared plus 7x. And we should be in a situation which is, familiar to some of the other ones. We got to set this equal to 0. Bring the 6 back over. 0 equals 5x squared plus 7x minus 6. So now if you see, we're going to find the 0. 0 equals 5x squared plus 7x minus 6. 0 equals 5x x. That's the only way to get 5x squared. Since this is minus, one's a plus, one's a minus, I'll just do that for now. 6 is either 1 and 6 or 2 and 3. We're just going to guess until we get there. Let's try 2 and 3. This is positive 2x minus 15x, which is negative 13x. I wanted 7. That's not correct. So I'm going to erase. Let's try flipping them. Let's put the 3 here and the 2 here. 3 times x is 3x. 5x times 2 is negative 10x, which is negative 7x. All right, so we were close. We got the right number, just the wrong sign, so I guessed pretty well. So these numbers in the right spots, but I got to switch the signs to make this a minus and make this a plus. Again, just one more check. Negative 3 times x is negative 3x. 5x times 2 is plus 10x, which is positive 7x, which is what I want. Okay, so I have two things being multiplied equals 0. Either 5x minus 3 equals 0, or x plus 2 equals 0. Add 3 to both sides. 5x equals 3. Divide both sides by 5. X equals 3/5. Let's do this one. Minus 2. X equals negative 2. And I'm going to reject this answer because negative 2 does not make sense. You can't have a negative answer because for the first time we're applying it to a real world situation, you can't have a negative distance. You can't tell me that the length is negative 2. It doesn't make sense. Can you have a fractional? You sure can. That's why 3/5 is the answer. You probably should verify and check and say that x is 3/5. So if I redraw my triangle, this length is 3/5, and this is 5 times 3/5 plus 7, which of course 5 times 3/5 is 3 plus 7, or 10. So the question is, what's 10 times 3/5? 10 times 3/5, which is the area. Area is 10 times, well, 3/5, as we all know, is 0.6. So area equals 10 times 0.6, or 6, which is what we wanted. So that's not the answer. The answer is what's the width, which is x, which is 3/5.